Okay, how's it going, everybody? This is the second video on programming in ARM assembly, and specifically for homework number 3 in Computer Science 411. So the next thing we're going to cover here is how to loop and how to deal with arrays. So one of the things you have to do in homework assignment number 3 is uh, multiply two arrays together in various ways. And I'm not going to go over how to do that exactly because be a little bit of academic dishonesty, but I will show you how to loop over an array and do something with that array. So let's just rename this variable to array. And how you declare an array in the data section is you just use commas. So I want this array to start out with the values 4, 3, 2, and 1. So this, what it actually does is it reserves 4 consecutive words, and that will be your array. You can index that using a little bit of math that I'm going to show you. Just a note on compatibility. If you're compiling a program like this, you want to tell the compiler where the entry point of the program is. The entry point is just where your program starts. So to do that, we're just going to declare a global called start with an underscore. And then we're going to label this start. I forgot the underscore. So that just tells the compiler and other programs, if they wanted to include this code, this is where our program starts. So obviously you don't need that for ARMSim because we did that in the last video without a global start label, and it worked fine. But I'm not sure about other simulators or things like that. They might need this. All right, so now let me show you how to actually index this array. So we want to load into register 0 the location of the array. And in register 1, here, let's actually delete this code. In register 1, we will keep the index into the array. So we'll actually load 0 into register 1, and we're going to index that later, or increment it later, I should say. And that's going to allow us to index the array. And let's make another 0 in register 2. And what this will be is our running total. So we're going to sum up everything in this array into one number. So that will be our running total. And this is our index. Okay, so now on to looping. What you need for a loop is somewhere to jump back to, right? That's how looping works, is when you finish one iteration, you jump back to the start, right? So we need a label. So we'll call it loop. And here in the loop label, we're first going to get an element out of the array. So how you do that is also using the LDR command. So a lot of these, I mean, anything when it comes to memory is going to involve loading using the LDR command or a similar instruction. And we'll load into register 3. And we will index the location at pointed to by register 0 with an offset that is stored in register 1. So basically what this is doing in these brackets, here, let me increase the font size if I can. A little better. Okay, so hopefully you can read that a little better. So the brackets here obviously mean that this is a memory location that we're trying to access. And what this means is that the memory location is given by register 0, and then we need to move forward by an amount specified in register 1. So it's register 0 offset by register 1. And we're going to take the word that's stored there and load it into register 3. So obviously this means that as you change or increase register 1, you're changing where in the array you're loading from. So now what we want to do is we want to take this value that we've just gotten into register 3 and add it to our running total. So we can just use add R2 is our destination. We want to add R2 to R3. So we're adding R2 and R3. We're taking our running total and we're adding this value we just got, and we're putting that back in R2 to update the total. So obviously what this is doing is it's summing up all the elements in the array. And once we're done that, next we need to just increment our index. And actually, I keep saying increment, but increment implies that it's being increased by 1. What it's actually doing is increasing by 4, right? Because a word is 4 bytes. So to increment, we actually add 4 to the register. So we're taking register 1, which is our index, we're adding 4 to it, and we're storing that back in register 1. So what's the other thing we need for a loop, right? We need to check the exit condition to see if we're done looping. So to check numbers like that, we use the compare instruction, which is CMP. So we want to compare register 1, which holds our index, and we want to make sure we're not going past the end of the array. So we want to compare register 1 to, what's the last index in our array? It is, so we have 0 bytes, 4 bytes, 8 bytes, 12 bytes, and out here 16 bytes. So we want to compare to 16. And if it's greater than or equal to 16, then we know that we're done. So now that we've compared, that has set the flags register, and we can use a branch instruction, conditional branch specifically. And a conditional branch will look at the flags register, and depending on which conditional you use, will decide whether or not to branch to a new location. So in this case, we're actually going to use BGT, which means branch if greater than. So this will say, if register 1 is greater than 16, we want to branch, which just means start executing code from a new location. So we're going to branch to end, and we'll say end is right down here. But otherwise, if we're not done and we still have more elements to add, we want to go back to loop. And how you do an unconditional branch is just B. So B means branch, and we'll branch back to loop. And so actually we need to store this value that we just got. When we finish looping, we need to put our sum of the array back into memory somewhere. So we're going to declare another variable in our data section. We'll just call it result. And we'll call it a word, and we'll give it a default value of 0. So down here in end, once we're done looping over this array, we'll just say str, and we want to store our result, which is in R2. And we want to put that in a memory location. And to get that memory location, we'll just load a register. We'll just pick a random register, pick R4 since we haven't used it. We'll give that the pointer to result, and we'll use that as the memory location. All right, so that should be it. Let's head over to ARMSim, and you don't need to use the file load button. You can actually just use the recents list down here and click your file just to reload it. And as you can see, our file's been reloaded. And I'm just going to hit run and run this all the way through because we have no errors, and we'll see if anything pops up while we're running it. It looks like it ran okay, but to double check, I'm just going to view the memory. So you can already see over here, register 2 has the value A, which is hexadecimal for 10. But we're actually going to check the memory location just to make sure. So word 0 is our result, and we stored the location of that in R4. So we'll look at register 4, and we see that that memory location is 1050. And right here, you can see at location 1050, we have 0A, which is also hex for 10. So that's the correct total. That's it.